Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Let us solve some exercises about power series. Find the radius of convergence and interval of convergence of the power series. We have seen that we need to use either the ratio test or the root test. And since I have here n to the power 1, there is no nth power for n, so I will use the ratio test. Negative 1 to the power n plus 1 times n plus 1 times x to the power n plus 1. This is a n plus 1. And this is a n. Some cancellations. This goes with this and negative 1 remains. And also here I still have x. So I will have absolute value of negative 1 is 1. So I still have n plus 1 over n times absolute value of x. N plus 1 over n are positive numbers. That's why we do not write absolute value. But x could be positive or negative, so we have to put absolute value. Now, when we take the limit when n approaches infinity, the limit of this is 1. So this goes to absolute value of x. So by ratio test, this series is absolutely convergent if absolute value of x is less than 1. This means that the radius is 1. This is the radius of convergence. And solving this equation, this interval, x is between negative 1 and 1. So the interval of convergence is negative 1 to 1. But we have to study the endpoints of the interval individually using other tests. So when I replace x in the definition of the power series by negative 1 in the exercise, so I have negative 1 to the power n times n times negative 1, replacing x by negative 1. And now we have this to the power negative n, this is to the power n, so I can write it negative 1 times negative 1 to the power n times n, and this is 1 to the power n, and it is 1. So in fact, the series is summation of n from 1 to infinity. And this series is divergent by test for divergence. Since the limit of an, which is n, when n goes to infinity, is infinity. And the case if x is 1, I will have summation negative 1 to the power n times n, and 1 to the power n would be 1. So this would be the series. And this is also divergent by test for divergence, because limit negative 1 to the power n times n when n goes to infinity does not exist, because we have seen that the limit of n is infinity, so this will give you plus or minus infinity. It's not 0, does not exist in fact, so this series is divergent. So the interval of convergence is from negative 1 to 1, and negative 1, 1 are not included. So this is the answer. This is the radius of convergence 1, and this is the interval of convergence. Again, I will use the ratio test. replacing n by n plus 1, divided by or multiplied by the reciprocal of an. Cancellation. And its absolute value of -1 is 1, absolute value of x is absolute value of x times cube root of n. There is no need of the absolute value here because n is a positive number. So that's it. If I take the limit of this quantity when n goes to infinity, it goes to 1. So this goes to absolute value of x. So by ratio test, the series is absolutely convergent if absolute value of x is less than 1. So this again means that the radius of convergence is 1 and x is between -1 and 1, and we have to consider these two cases. If I take x -1 to the power n will be multiplied. It would be 1 to the power n. So I will have 1 over cube root of n. Well, this is a divergent P series because P is 1 over 3 less than 1. While if x is 1, I'll have 1 to the power n, which is 1, so I still have -1 to the power n over cube root of n. And this is an alternating series, so I'm going to use the alternating series test. In fact, this series is convergent by alternating series test. Since limit bn, which is here, 1 over cube root of n when n approaches infinity is 0, and 1 over cube root of n plus 1 is less than 1 over cube root of n, which means bn is decreasing. So the interval of convergence in this case would be -1 is divergent, so it's not there. But 1, the series is convergent at 1. So this is the interval of convergence of this series. I have n here, so again, I am using the ratio test. Multiplied by, or multiplied by. In the denominator, I have 5 to the power n. In the numerator, I have n times x to the power n here. So this would be the reciprocal. Cancellation. So I have n plus 1 over n and absolute value of x over 5. The limit of this when n goes to infinity is 1. So this would be the limit when n approaches infinity. And by ratio test, this series is absolutely convergent if absolute value of x over 5 is less than 1, means absolute value of x is less than 5. So the radius of convergence is 5. If you have any problem with the radius of convergence, see the previous video, please. And the interval of convergence is between -5 and 5, but we have to check the endpoints individually. So I will have summation n times -5 to the power n over 5 to the power n, and the same power, so I can write it -5 over 5 to the power n, and this will give you -1 to the power n times n. And we have seen that this is divergent by test for divergence, since the limit of -1 to the power n times n when n approaches infinity does not exist. While when x is 5, I will have 5 to the power n, and it would be cancelled with 5 to the power n. So I have summation n. And this is divergent by test for divergence, since limit n when n approaches infinity is infinity, not 0. So the interval of convergence is -5 and 5 open, because these two series are divergent. I think this is the same series as the previous one, but the reciprocal. 5 to the power n is in the numerator now. So what would happen? What would be the effect? Let us see. This is an plus 1. Notice that this is x to the power n over 1, so it's multiplied by 5 to the power n, multiplied by n over well, this time this would be equal to n over n plus 1 and 5 and absolute value of x. The limit of this is 1 when n goes to infinity, so as n goes to infinity, this will go to 5 times absolute value of x. And by ratio test, series is absolutely convergent when 5 times absolute value of x is less than 1. This means that absolute value of x is less than 1 over 5. This means that the radius of convergence is 1 over 5. And x is between -1 over 5 and 1 over 5. And we need to consider the endpoints individually. So I will have 5 to the power n over n, and I replace x by -1 over 5 to the power n. So I have, in fact, this power n, so I can multiply what is inside, so 5 times -1 over 5 all to the power n times 1 over n. This will give you -1. 5 cancels with 5. So the series is -1 to the power n times 1 over n. And this series is convergent by alternating series test. Since limit 1 over n when n goes to infinity is 0, and 1 over n plus 1 is less than 1 over n, so it is Bn is decreasing. While when x is 1 over 5, 5 to the power n times 1 over 5 to the power n would be 1. So I'll just have 1 over n. And this is the divergent harmonic series. So the interval of convergence would be at negative 1 over 5, the series is convergent. At 1 over 5, it is divergent. So this is the interval of convergence, and this is the radius of convergence. And you can also check at the end what is the center here. The center is 0. X to the power n means the center is 0. And 1 over 5, negative 1 over 5 are the endpoints, and the radius is this distance. This distance is the radius. So everything is good. Similar questions, similar methods using the ratio test. You should pause the video every time with each question and try to solve it by yourself and figure out your mistakes. What is the point that you do not understand? So absolute value of x over 3 and I have n over n plus 1. When n goes to infinity, this will go to 1. This means that the radius of convergence is 3. And x is between negative 3 and 3. When x equals negative 3, negative 3 over 3 all to the power n will give you negative 1 to the power n over n. And we have just seen that this is convergent by alternating series test, because limit of 1 over n when n goes to infinity is 0, and 1 over n plus 1 is less than 1 over n. While if x is 3, I'll have 3 to the power n. It will be cancelled with 3 to the power n. And this is the divergent harmonic series. So at negative 3, it is convergent. At 3, it is divergent. So this is the interval of convergence. Just replace n by n plus 1. Well, here I have 2n plus 2 minus 1, that's plus 1. So I have 2n minus 1 over 2n plus 1, and all of these are positive. N starts from 1, 2 minus 1 is positive, so but absolute value of x, because x need not be positive. If n goes to infinity, this will go to 1, 2 over 2. So by ratio test, Series is absolutely convergent if absolute value of x is less than 1, and this is the radius of divergence, and x is between -1 and 1. If x is -1, I'll have -1 to the power n over 2n minus 1. And this is convergent by alternating series test. Since the limit of 1 over 2n minus 1 when n goes to infinity is 1 over infinity, that's 0. And 1 over 2n, if you replace n by n plus 1, we have seen that the answer is 2n plus 1 is less than 1 over 2n minus 1 because 2n plus 1 is greater than 2n minus 1. So this means that Bn is decreasing. So this series is convergent. While if x is 1, I'll have 1 to the power n, which is 1 over 2n minus 1. And this series, I will compare it with the series 1 over n, because this is the highest power, or 1 over 2n. It's both are okay. This is the divergent harmonic series. And well, it's okay. I'll use 2n. I can use the limit comparison, but I figured out that I can use the direct comparison test. 2n, this is a multiple of, okay, multiple of the divergent harmonic series, so it's divergent. Since I have 2n minus 1 is less than 2n, then 1 over 2n minus 1 is greater than 1 over 2n when you take the reciprocal. So by direct comparison test, series 1 over 2n minus 1 diverges. Okay, because greater, this what the direct comparison test says, greater than divergent is divergent. So at -1 it is convergent, at 1 it is divergent. And this is the interval of convergence. If you do it step by step like this, and if you studied all the previous tests, sections, it would be easy for you. So this would be absolute value of x over n plus 1. N plus 1 factorial is n plus 1 times n factorial, so they cancel and you get n plus 1. And now when n goes to infinity, absolute value of x over infinity is 0. So this goes to 0. And 0 is less than 1. Okay. I can say by ratio test, yeah, this is less than 1. So series always absolutely convergent for all values of x, because it's always 0. So the radius of convergent is infinity, and the interval of convergence is from negative infinity to infinity. Well, I have n to the power n times x to the power n. So I can solve this by the ratio test. But it's nice to use the root test because finally we can use the root test for some uh, series. If you find the nth root of n xn, absolute value, the nth root of n would be n. The nth root of x to the power n is absolute value of x. N cancels with n, and do not forget the absolute value of x. Now, when n goes to infinity, this will go to infinity. So by ratio test, series diverges. But we know that if x is 0, only if x is 0, except at x equals 0, because 0 is the center. Notice that 0 times infinity is an indeterminate form, and if you replace x by 0 here, you will get summation 0. So it converges to 0. So the interval of convergence here, just the center, which is 0. And the radius of convergence is 0 because I did not move from the center. Not because the center is 0, the radius is 0, no. Because it is the center, even if the center is 1, for example, and it converges at 1, then the radius would be 0 because we did not move from the center. Here I will use the ratio test. Cancellations. Okay, I have 2. I have absolute value of x. I have n plus 1 square over n squared. The limit of this is 1 when n approaches infinity. So the limit is 2 square root of x. Series is absolutely convergent if 2 times absolute value of x is less than 1. This means that absolute value of x is less than half. So the radius of convergence is half, and the interval is between negative half and half. But we have to consider the endpoints using other tests because the ratio test fails at the endpoints. If I replace x by negative half to the power n, this is power n, this is power n, so I can multiply 2 times negative half to the power n times n square. And 2 cancels with 2, and I'll have negative 1 to the power n times n square. And this is divergent by test for divergence because limit negative 1 to the power n square when n approaches infinity does not exist because limit n square is infinity. While if x is half, then when I replace x by half to the power n, it will cancel with this. 2 to the power n over 2 to the power n would be 1. And I'll have summation n square. And this is divergent by test for divergence, since limit n square when n goes to infinity is infinity. So the interval of convergence is the open interval negative half to half. This is n plus 1 below. Okay. So negative 1 to the power n plus 1, 4 to the power n plus 1, x to the power n plus 1, all over square root of n plus 1. Square root of n only. Cancellations. So absolute value of negative 1 is 1. I have 4 times absolute value of x times square root of n over square root of n plus 1. The limit when n goes to infinity for this is 1. So this go to 4 absolute value of x. By ratio test, series is absolutely convergent if 4 times of x, absolute value of x is less than 1, which means absolute value of x is less than 1 over 4. So that's the radius of convergence, and x is between negative 1 over 4 and 1 over 4. Let us consider the cases, the endpoints. If I put negative 1 over 4, let me do it. So since all these three has power n, I will use the property and multiply all of them together. All to the power n. Negative times negative, positive 4 over 4 is 1, so it is in fact 1 to the power n, which is 1. And this series is divergent, P series, because P is half and half is less than 1. While if x is 1 over 4, I'll have here 1 over 4. So I will have negative 1 to the power n over square root of n. And this is convergent by alternating series test. Since limit of 1 over square root of n is 0, and 1 over square root of n plus 1 is less than 1 over square root of n, so Bn is decreasing. So the interval of convergence is at negative 1 over 4 it is divergent, but at 1 over 4 it is convergent. I'll stop here and continue more examples in another video.